This is the second example on horizontal stretching and compressing. Notice that in this case, I have the number inside of the function is a fraction. Whenever the number inside of the function is between 0 and 1, this indicates that the function will have a horizontal stretch by a factor of 1 divided by this number. So when I describe this function in my own words, I will say that this function has been horizontally stretched by a factor of 1 over 1/3, which is equivalent to 3. There is no reflection here because I have no negatives. The parent function, and I'm going to state what the parent function is. The parent function f of x is equal to x cubed, has been horizontally stretched by a factor of 3. That tells me that all the x coordinates of my parent function will be multiplied by 3. So let's get some coordinates for my parent function. When x is 0, 0 to the third power is also 0. When x is 1, 1 to the third power is 1. When x is 2, 2 to the third power is 8. My next number is 3, but when I raise 3 to the third power, I get 27, and that value will not fit in my graph, so I will not work with that number. So let's plot these 3 points for my parent function, 0, 0, 1, 1, and 2, 8. So 0, 0, that's the origin, 1, 1, and 2, 8. Now, this function, x cubed, is an odd function. That means that all of these points that exist in the first quadrant will also be on the fourth quadrant. Because this function is odd, it means it is symmetrical with respect to the origin. So if 1, 1 exists, so will negative 1, 1. And if 2, 8 exists, so will negative 2, negative 8 exist. There's the parent function x cubed. Now I will start creating the horizontal stretch by a factor of 3. So what we do is we get our coordinates for our new points. And since this is a horizontal stretch, my y values will remain exactly the same. And my x values are the ones that are going to change. So I take each x value and I multiply by 3. 0 times 3, 0. 1 times 3, 3. 2 times 3, 6. I plot these new values. 0, 0 you keep. 3, 1. 6, 8. And remember that all these values that exist in the first quadrant also exist in the fourth quadrant. So 0, 0, instead of 3, 1, I'm going to go negative 3, negative 1, and negative 6, negative 8. And here's my final sketch. I will do this in a solid line because this is my final graph. You can see that the parent function, this original point, has been stretched that way by a factor of 3. And this point here has been stretched that way by a factor of 3. Same thing over here. This value has been stretched over by a factor of 3, and so is this one. That's why it's called a horizontal stretch. And remember to label your function. F of x is equal to 1/3 x cubed. And there you have it. In our next example, we will sketch a more complicated function with reflections, vertical translations, horizontal translations, and horizontal stretching or compressing. I'll see you in the next video.